So in this video I will show you how to make a Bluetooth and Arduino IoT Cloud enable esp32 and DHT22 sensor based temperature and humidity monitor. Actually I am making this for one of my school life photographer friend. He wants to monitor the humidity of his camera box. So I had to make this and I thought let's make a tutorial video on it. In this tutorial I will show you full circuit diagram, hardware configuration and how to integrate with Arduino IoT Cloud from scratch. So to start the project we have to bring all components. For that I am going to Chandni Chowk. You can also buy components from online services like Amazon or Robo, but Chandni Chowk is less cheaper than those online services. So let's go to Chandni Chowk and bring all parts. And when I am talking about Chandni Chowk, I am talking about Kolkata Chandni Chowk. So let's go there. Okay, now let me show you exactly which components I am using for this project. As a main microcontroller, I am using this esp32 board. It comes with onboard Wi-Fi and Bluetooth, so I can connect it with Wi-Fi, and through the internet it will connect with the Arduino IoT Cloud, and also I can use Bluetooth for connecting directly with my mobile. This is my main sensor DHT22 for temperature and humidity monitor. This is the main and one and only sensor in this whole project. This is a connecting cable I got with the sensor. Otherwise I have to bought female to female jumper from external sources. And this is a common cathode RGB LED. It will indicate the status of the humidity. These are 5.5mm DC jack and base to power up the whole system. And finally this small box to add all components and make a compact design. Comparing with esp32, this board is very small because of these pins, so I have to remove these pins from the esp32 board because we only need 3 wire connect with the esp32. We don't need this much header pins, so let's remove it. Removing these all pins will not be easy that much because soldering is easy but desoldering is not. So these all are all components. Let me show you how to make it. So let me show you the circuit diagram of the project. In this project we are using this much components. These are very few components. Our main microcontroller is esp32, as you can see here. This one is a esp32 DevKit V1 version, and this is a DHT22 sensor. DHT22 sensor have 3 pins: VCC for 3 volt or 5 volt, data for data output, and ground. This is a 5.5mm standard barrel jack to power the whole system using a 5 volt DC adapter or mobile charger, what you can use. And this is a common cathode RGB LED to indicate the humidity level without any mobile, just for visual. And this is optional. This is actually a reset button. Actually you have a reset or enable button on esp32, but when it will inside the box you cannot access the onboard button. That's why I had used here a button also, but in most of the cases we don't need the reset button in the project. I also had not attached it in my box, so you can skip this button also. So here is only 5 components here. Now let me talk about the wiring. At first the power connection. This is a 5.5mm barrel jack. It have 3 pins. One of them is useless, that is off, and 2 are useful. One is VCC or V plus, which will connect with the V in pin of the esp32, and the second is ground. Ground will be connect with the ground of microcontroller or the all ground of the total circuit. This is the main sensor DHT22. As I had told you, it has 3 pins. The VCC will connect with 3.3 volt. You can also attach it with 5 volt, but 3.3 volt is the good choice, I think. And there is a ground pin in the DHT22. You have to connect it with microcontrollers or any of the ground in the total circuit. And there is data pin, which is the main data output. I had connected the data output with the D4 pin of esp32, but you can use any another pin for your project. But you have to notice that unlike Arduino or other microcontrollers, we cannot use all of the GPIO pins of esp32 for general purpose input output. There are specific other pins which have other purposes, so we have to select the proper pin for the input and output. So I had selected the D4. You can also use D33, 32, 35, D22 or D23. These pin are good for input and output. Now talk about the RGB LED connection. This is a common cathode RGB LED. It means it have a common ground and for a different color we have different positive sides. So the ground is connected with the total circuit's ground, and red pin is connected with D27, green pin is connected with D26, and blue pin is connected with D25. And there is a enable pin also. You have to attach a button between the enable and ground, so that when you press the button, the enable, which is by default input pulled up, it will turn into ground and the board will reset. So this is the full schematic diagram, very easy, very few components are there, and wiring is also easy. I will give you the total schematic in the description box, you can download it from here. You just have to remember 4 pins for programming. One is data output, which is connected with DHT22, and others is the red, green and blue LEDs pin. You have to mention these pin numbers in your programming so that your project works properly. So here I had already prepared the case for the humidity monitor. This is the small box. These two screws are to attach this box with the main dry box, and this is a RGB LED. It will show if the humidity is over the limit or right position or under the limit. 3 color LEDs to indicate 3 states. This is DHT22 sensor. I had also attached it with a 3mm screw. All screws are 3mm size, and this is the signal wire. It will go inside of it using the pre-made hole, and this is the bottom side of the box. As you can see, I had attached it with the box using again 3mm size screws. I had already removed the header pins from the esp32, that's why it's fitting inside it pretty good. And now I have to solder this DHT22 sensor and the LED with the esp32 module. Red one VCC, this brown one is ground, and this is the signal. So let's solder it. And yes, all these hole are made using my this DIY drill bit. This is a 775 motor with a 775 motor 5mm mount drill bit. This is a 3.25 mm drill bit, so this is more than enough for me. Buying a drill is not cost effective for me because I don't use drill regularly, so this is the best option for me. Okay, as you can see, my soldering is already completed, and these 3 are for the sensors wire. Positive 3.3 volt, ground and DHT pin, and here is a ground for RGB LED ground, and here is 25, 26 and 27 connected for RGB LEDs red, green and blue. So with this our hardware soldering is completed. Just I will put these header pins into the LED pins. I am keeping all the places using the header pins because you can easily switch any modular LED without any soldering if you do in this way. I had also connected the LED pin with the esp32. Now the hardware is fully complete. Now we just have to complete the programming part. So this is the final look of the IoT humidity monitor. This is DHT22 connected to the box with a 3mm screw. These 2 screws are to hold this all thing with the dry box's wall. This is RGB LED to indicate the humidity level inside the box, and these 2 screws are actually holding the esp32 inside the box. This is a standard 5.5mm barrel jack female to power this whole thing up. So I had decided to make a separate video how to program the esp32 and how to set up the full Arduino IoT Cloud, because already this video is too long and I have to properly explain the programming part and the IoT setup part. That's why I will upload a separate video on this as quick as possible. So this is the humidity monitor I had shown you before, and here I am setting up the Arduino IoT Cloud for it. I will make a details tutorial video how to set up Arduino IoT Cloud from scratch and coding also. And this is our dry box which we will use for this humidity monitor, and this is the majestic camera Sony Alpha 6400. Here I had made the full interface for the Arduino IoT Cloud mobile app. At first, here is the humidity, and this is the graph for the humidity. Here is heat index, temperature and graph for those, and here our mobile interface is ready. At first, here is humidity, then humidity graph, then heat index, temperature and other graphs. Till this hardware is not ready, that's why here the data is not available. After some time it will live. So here our code is completely ready. and I am compiling it. Currently it's compiling. This is our hardware connected with the data cable, and we are waiting for the data display on the ARDUINO IoT cloud. Our code is successfully compiled and now uploading. Let's check what happens. Code uploaded. I'm opening the serial monitor, finding DHT22 sensor is found, and we are getting our humidity and temperature. Currently Wi-Fi is not connected. It will connect in 4 seconds. Here it is successfully connected with our Wi-Fi ChayVC 2.4G, and here you can see the live humidity is showing, also the live humidity graph and heat index and temperature with graph also. So our project is complete in technical term. Now we have to set up the full device inside the box. So here our dry box is ready. You can see here is a mirrorless camera's lens inside. We had set the humidity sensor with 2 screws, and this is a 5.5 millimeter jack. It's powering up using a normal 5 volt adapter. And here is our live data coming from the humidity box directly over the internet. This is ARDUINO IoT cloud. Recent humidity is 64%, and it's declining as you can see in the graph. And this is the temperature and heat index also. So our project is fully successful and working perfectly fine. Here is the indicator LED also. It is glowing in red because the humidity level is more than 45%. If the humidity level is less than 45, then it will turn into green and then glow. So this was our full project. Right now I am in Kolkata and my friend's camera box is at Bankura, but from here I can watch his camera box's humidity and temperature level. As you can see, he is maintaining his camera box very properly. It's 31%, the perfect humidity level for camera boxes. And this is the graph. You can watch in 1 hour here. This is a pretty good quality graph here, and here is also Bakura's temperature and heat index and with graph also. So in this way we can live monitor our camera box's temperature, humidity, everything in live time from anywhere using the internet. And as you can see, his camera box's device is currently online. Its name is Box Buddy, so it's showing me online if it is connected with Wi-Fi or not. So this was a tutorial video on how to make a DHT22 sensor based humidity and temperature monitor for dry boxes and camera boxes type of purposes integrated with ARDUINO IoT cloud. I am attaching the full circuit diagram schematic of the project in the description box. If you want, you can download it from here. And the programming and IoT cloud integration video will upload as quick as possible. So that's it for today. Hi, I am AkashWave, call sign Victor Uniform number 3 Hotel Alpha X-ray. I am an electronics and communication engineering student and a licensed ham radio operator also. I used to make videos on microcontrollers, microprocessors, sensors, ham radio, antenna, RM modules and this kind of stuff. So that's it for today. See you on another video. Bye.